Welcome back to Module 12, Lesson 5, where we're going to learn to find or use nets to find surface area of three-dimensional objects, also known as polyhedrons. But before we get into that, let's do a little review. Here we have a triangle, and if you recall, I gave you three different formulas that you can use for the area of a triangle. All three formulas get you to the same direction. The formula that I prefer to use most of the time, oops, that's not a very good color, let's try this again, is going to be area is equal to base times height divided by 2. If I'm working with a fraction, I like to use area is equal to 1/2 times base times height. And you could also do it this way with a vinculum. Area is equal to 1/2 base times height divided by 2. All three of those are legitimate formulas for finding the area of a triangle. Like I said, if I have fractions, I always use the middle one. If I have decimals or whole numbers, I generally use the first one, and I just have never really liked the last one. Don't know why, just never have. So let's take a look at some other things. You've got a whole bunch of numbers on this triangle. If you remember, something else I've taught you is that your base and height always meet at right angles. And right here is a right angle, so my height is going to be my 12, and my base is going to be this distance which goes across here. Well, that distance is 5 and 9 together, which is going to be 14 centimeters. So when I plug it into my formula, I would end up saying that area is equal to, I have a base of 14 centimeters times a height of 12 centimeters, all divided by 2. From here, I have choices. I could take and multiply 14 times 12, wouldn't be a lot of fun, or I could take half of 14 or half of 12. Both 14 and 12 are even numbers, which means taking half of them would be pretty easy. So that's what I'm going to do. I'm going to take half of 14, and that's going to give me 7 centimeters times 12 centimeters. 7 times 10 is 70, 7 times 2 is 14, and 70 plus 14 is going to give me 84. Centimeter times centimeter is centimeter squared. And it doesn't matter which of those three formulas you use, the answer would be the same. But I think I might have gotten ahead of myself with that. The first question said write a numerical equation for the area of the figure below, and I did that. I've written a numerical equation right here, and then explain and identify the different parts of the figure. And I did that vertically, or verbally I should say. Did the 5 and the 9, that's going to add up to be 14 for my base. The height is going to be 12, and these two, they're just sides of the triangle. That means absolutely nothing to me. How would you write an equation that shows the area of the triangle with base and height? Well, we did that right there, so that's going to be our part 1 and our answer to part 2 there. And then part B says write a numerical equation for the figure below. Well, if you remember, the formula for the area of a rectangle is area is equal to length times width, or area is equal to base times height. Once again, both of those are perfectly good formulas. There's no reason to use one over the other, which means that area would be equal to 28 feet times 18 feet. Now, part 2 says, how would you write an equation that shows the area of the rectangle using base and height? That would end up being a note. It didn't ask me to solve it right here. It just asked me to write a numerical equation for the area, which I've done. Explaining the different parts. 28 is going to be my length, and my width is going to be 18. And if you remember, it doesn't matter which order you put those in. Part B wants us to take and use this formula. Area is equal to base times height. So area is going to equal to, this time I'm going to have my base be the 28 feet and my height be the 18 feet. And it says, how would you write an equation that shows it? It doesn't ask us to solve it right now. It just asks us, how would we write the equation? So that's going to be our quick little refresher on some formulas. From here, we're going to take a look at some nets. Now, they have taken this net of a rectangular prism. In the real world, it's going to look kind of like this, where you've got 4 skinny sides and 2 square sides coming together in order to make it's a rectangular prism, but it's also a square prism because the opposing faces are squares. So what we have to do is we have to take and find the area of all the different parts in it. And we're going to need to do all rectangles. Yes, I know one or two of them are squares, and squares are rectangles. So what I'm going to do is I'm going to use the area equals length times width formula. And I've got two different rectangles in the end that I'm going to need that formula for. One of them is going to be a 2 by 2. The other one is going to be a 1 by 2. So I'm going to write my formula twice. So first one, I'm going to set area is equal to, so if we did this one, I have a height of 1 and a width of 2. So we could take and do that as if we said that this was your length and that was your width, or this is your length and that was your width. It doesn't matter. 2 times 1, area is going to equal to 2. And now I can take and put a 2 inside every one of the rectangles that is a 1 by 2 rectangle, showing me that that's going to be what their value is. Then I'm going to go to the other rectangles, which are also squares, and those are 2 by 2 rectangles, giving me areas of 4. Now I'm going to circle both of these, not because they're the answer, but they are important sub-answers. And then I'm going to take and write those 4s inside the squares. All of my shapes have numbers in them now. All I have to do is add them up. So to finish up my problem, I'm going to come off to the side here. I have a 4, a 4, a 2, a 2, a 2, a 2. And when I add all those numbers up, I'm going to get 12. So the SA, or surface area, is equal to 12 units squared. Pretty easy, isn't it? Scrolling down to the next one, this time I have triangles and I have a square. Now, all of my triangles are going to be the same. They're all going to have a base of 3 and a height of 2. You see right here, that base and height meet at right angles. Every single one of them is going to have the same base of 3 and height of 2. So I'm going to need two formulas for this. I'm going to need one formula for the area of the triangles, which is going to be base times height divided by 2, since all my numbers are whole numbers. I'm also going to need a formula for the area of the square, which we're just going to treat it as a rectangle right now. Area is equal to length times width. Plugging in my values for my triangles, they all are going to have a base of 3 and a height of 2, all divided by 2. Now I have choices at this point. I can do 3 times 2, I can do 3 divided by 2, not fun, or 2 divided by 2, which wouldn't be a bad way to do it. But this time I'm going to do 3 times 2, which is going to equal to 6, divided by 2, so the area of all my triangles are going to be 3. That didn't write very well. Let's try that again. Units squared. And I'm going to use a different color just so it'll pop here a little bit. 3, 3, 3, and 3 goes into all my triangles. Next, my square is going to be 3 by 3, so the length is going to be 3 units and the width is going to be 3 units, giving me an area of that square is going to be 9 units. We're going to circle both of those sub-answers because they are important, and then all we have left to do is add those numbers up. So I'm going to take and put another line here to keep my work neat and organized, and then I'm going to take my 9 plus 1, 2, 3, 4 3s. That's going to be 12 plus 9, which is going to give me 21 units squared, is going to equal to my surface area. Pretty easy math, isn't it? So at this point, what's going to happen? Well, you are going to be working with your partners to solve these 4 problems. We have question 1, 2, turn the page, and you've got 3 and, 4. I'm pretty sure that's it. I think after that you start getting into your assignment problems. So go ahead and pause the video and work those problems with your table partners. So how'd that end up working out for you? For question number 1, I had 4 triangles that were all the same size and 1 square. So I found the area of each of my triangles, which was going to be 6. I found the area of my square, which is going to be 16. Writing those numbers into the spaces where as I go, added them up to get a total of 40 units squared. For the next problem, I had 2 different size rectangles. One rectangle was a 2 by 5, and there was 4 of those. The other rectangle was also a square at a 5 by 5, and there was 2 of those. So I found the area of each one of those, added them up to get a total area of 90 units squared. Turning the page for problem number 3, this one I almost made a mistake on. This one I almost assumed that my triangles were all the same size. But then when I got to my rectangle, I realized, ooh, wait a minute. The sides of my rectangle are 4 by 3, which means my triangles are different. So I had 2 triangles that had an area of 8 units squared, 2 triangles that had an area of 6 units squared, and 1 rectangle that had an area of 12 units squared. All those added up to be 40 units squared. For my final problem, I went up down to here, and I had 3 different size rectangles. One was a 1 by 6. One was going to be a 1 by 4, 2 or 1 by 6, 2 or 1 by 5, and 2 were a 6 by 5. Added up gave me a total of 82 units squared. This is where you dive into your individual homework assignments. These are individual activities, not group activities, where you're going to answer questions 1, 2, 3, and yep. From there, you got question 4. And you got question 5. So you got lots of things to work on tonight. Shouldn't take you too long to do it because all this stuff is pretty simple. I look forward to answering any questions you have, and I look forward to seeing you in class tomorrow.